People say everything in the universe is spinning because of angular momentum. That sounds very respectable. It has big words, but it doesn't really explain anything. That's just a label, like saying a man sleeps because of a dormitive virtue. Fine, you've named the thing. But why should angular momentum be there in the first place? Why should matter, which could just as well sit quietly, insist on twirling like a child who's had too much sugar? Look around. Galaxies spin, stars spin, planets spin, hurricanes spin. Even the little things, atoms, have this strange built-in whirling. You can hardly find anything in nature that just sits still unless it's nailed down. And even then, the atoms inside are jittering like mad. The usual story goes like this. In the beginning, there were clouds of gas. They collapsed under gravity. Any tiny rotation got amplified, so the whole thing started spinning faster, like a skater pulling in her arms. That's all perfectly correct. But it dodges the real irritation. Where did that tiny rotation come from? Why wasn't the cloud perfectly still? You might say, oh, random motions. But random motions don't prefer spinning one way over another. Randomness cancels out. If everything were truly symmetric, you'd get no overall spin at all. Zero, nothing, dead calm. Yet the universe is not dead calm. It's a carnival of rotation. Take something simple, a spinning top on a table. You flick it and it spins. No mystery. You gave it a twist. But now imagine nobody flicked it. Imagine it just started spinning by itself. That would bother you. You'd start looking for hidden pushes, slanted surfaces, tiny nudges. The universe is exactly that problem, but worse. There's no obvious finger flicking it. Or consider a planet. Earth spins once every day. If it stopped, oceans would slosh, winds would howl, and we'd notice very quickly. Spin matters. It's not decoration. It shapes weather, time, and life. So it's fair to ask where the spin came from in the first place. Historically, people noticed this problem early. Isaac Newton knew that rotation was special. You can tell if you're rotating even in empty space. Spin a bucket of water and the surface curves. Something real is happening. It's not just motion relative to other things. That already hints that rotation is deep, deeper than pushing carts or throwing balls. Then along came Albert Einstein, who tangled space and time together and made things even stranger. Rotation started to smell like it was tied to the structure of space itself, not just objects moving around inside it. But I don't want to jump ahead. That's cheating. For now, just sit with the irritation. Everything spins. From galaxies the size of billions of suns down to particles you'll never see. We can describe how spin behaves beautifully. We can calculate it, predict it, use it to build clocks and computers. But the nagging question remains, why is spinning so unavoidable? Why isn't stillness the natural state? Once you take that question seriously, you're already halfway into trouble. And the next step is to ask whether spinning is even the right word at all. Now the standard rescue move comes fast. Conservation of angular momentum. People love this one. It sounds like a law handed down from the mountain. Once something is spinning, it keeps spinning unless you mess with it. That part is absolutely right. We can measure it, we can test it. It works every time. But notice something sneaky. Conservation laws never tell you where something came from. They only tell you it doesn't disappear. Saying angular momentum is conserved is like saying money in your wallet doesn't change unless you spend it. Fine. But how did the money get there? Let's do the skater trick. A figure skater starts spinning slowly with arms out, then pulls them in and spins faster. Beautiful. Predictable. We teach it to freshmen, but the skater had to start spinning already. Pulling in the arms doesn't create spin. It only reshuffles what's there. Same with collapsing clouds of gas. As the cloud shrinks, it spins faster. Yes, that's just geometry and bookkeeping. But again, it assumes some initial twist, a microscopic one maybe, but not zero. And zero matters. In physics, zero is special. If the universe really started perfectly symmetric, perfectly smooth, with no preference for left or right, clockwise or counterclockwise, then angular momentum should be exactly zero everywhere. But it isn't. You might say the early universe wasn't perfectly smooth. There were tiny fluctuations. That's true. We see them in the cosmic microwave background, little bumps in density. But fluctuations in density are not the same as fluctuations in rotation. Density is a scalar. Rotation is directional. It has an arrow to it. To get spin, you need something to break the symmetry. Here's where explanations start to get slippery. People say quantum fluctuations did it. That's another label. Quantum fluctuations are real, but they don't magically explain everything you don't understand. You still have to show how a fluctuation turns into a universal habit of spinning stuff. And notice something else. Spin doesn't just show up in big, messy systems like galaxies. It's baked into the smallest things we know. Electrons have spin, not because they are little balls spinning like tops. That picture fails immediately. If you try to imagine an electron as a spinning sphere, the surface would have to move faster than light. So forget that. Yet the spin is real. It shows up in experiments. It splits spectral lines. It makes magnets stick to refrigerators. You can't wish it away. So now the problem gets sharper. Rotation isn't just an accident of how clouds collapse or planets form. It's part of the fundamental bookkeeping of nature. Even when nothing is going around in space, there's still this stubborn rotational character. At this point, I like to slow down and get suspicious of words. What do we really mean by spinning? When a planet spins, you can point to parts moving around an axis, clear enough. But when an electron has spin, nothing is literally rotating in space. It's something more abstract, something built into the rules. So maybe the mistake is thinking of spin as motion at all. Maybe spinning is a lousy word that hides a deeper structure, the way force hid what was really going on before Newton cleaned it up. Maybe rotation is telling us something about how space itself keeps track of directions. If that's true, then asking why everything spins is the wrong question. The right question might be why the universe allows directions to mean anything in the first place. Let's get more concrete, because vague talk is where bad thinking hides. Imagine you're floating alone in empty space. No stars, no planets, nothing to look at. Now you start spinning. How do you know? There's nothing outside to compare yourself to. Yet you feel it. You get pulled outward. If you have a bucket of water, the surface curves. Something physical is happening. That already tells you something uncomfortable. Rotation isn't just motion relative to other objects. It's motion relative to something else. But what? This bothered Isaac Newton a lot. His bucket experiment wasn't a party trick. It was a warning. Linear motion is relative. Rotation is not. You can tell if you're rotating even when the rest of the universe seems gone. That's strange. Very strange. If motion were only about relationships between objects, rotation should disappear when the other objects disappear. But it doesn't. So rotation seems tied to the stage itself, not just the actors. Now look at a gyroscope. You spin it, and it stubbornly resists being tipped over. It doesn't care about your intentions. It behaves as if it remembers which way it's pointing. Remembering a direction in empty space is a remarkable thing. How does it know? Or take a Foucault pendulum. You set it swinging, and over hours its plane of motion slowly rotates. Not because the pendulum is doing anything fancy, but because the Earth is rotating underneath it. The pendulum is quietly insisting, no, this is the direction I was swinging in. Direction means something. So spin is not just motion, it's orientation. It's about how directions persist in time. This pushes us toward a dangerous idea. Maybe space itself has structure, not just distances, but directions that matter. If that's true, then objects aren't spinning relative to nothing. They're spinning relative to space. Now people get nervous here. They say, you can't talk about absolute space. Einstein killed that. Well, sort of. But he didn't kill the problem. He sharpened it. Albert Einstein showed that space and time are dynamical. They bend, they stretch, they interact with matter. That means space is not nothing. It's a thing that can have properties. So maybe rotation is interaction with that thing. But even that doesn't fully settle the irritation. Because if space has structure that defines rotation, why should matter couple to it in such a universal way? Why does everything from a spinning galaxy to an electron spin obey the same bookkeeping rules? Here's where the word spin really starts to crack. In quantum mechanics, spin doesn't come from motion through space at all. It comes from how the wave function transforms when you rotate your coordinate system. Rotate the world by 360 degrees, and some particles don't come back to the same state. They need 720 degrees. That's not spinning like a top. That's something stranger. So now we're stuck. Big things spin because of gravity and collapse. Small things have spin because of the mathematical structure of quantum theory. And both obey conservation laws that look eerily similar. That can't be an accident. It starts to smell like rotation is not a feature of objects, but a feature of how the universe counts possibilities. And if that's true, then the real mystery isn't why things spin, but why the universe insists on keeping track of orientation at all. There's a temptation now to say, all right, rotation is relative to space itself, and stop thinking. That's dangerous. That's how mysteries survive for centuries. Let's poke it harder. Why should space care about rotation at all? Why should it distinguish spinning from not spinning? If space were just a passive grid, a set of labels for distances, rotation shouldn't mean anything special, yet it does. Before Newton, people like Galileo Galilei worried mostly about straight-line motion. And there, things are beautifully boring. If you move at constant speed, nothing interesting happens. No forces, no stresses, no clues. That's inertia. Rotation ruins the party. Suddenly you feel forces. Things fly outward. Directions matter. So here's the key irritation. Nature treats straight motion and rotational motion very differently, and it does so everywhere, every time. Now imagine a universe with only two objects in it, just two balls floating in space. If they move apart, you can talk about relative motion. If they orbit each other, you can talk about rotation. Fine. But now strip it down further. One object, one lonely ball. Can it rotate? According to experiments and equations, yes. If it spins, it feels stresses. It bulges. It knows it's spinning. But relative to what? There's nothing else there. This question drove people slightly mad. One of them was Ernst Mach, who suggested something radical. Maybe inertia and rotation come from the influence of all the other matter in the universe. Maybe the distant stars are the thing you're really rotating relative to. That idea is seductive. It feels democratic. No absolute space. Everything defined by everything else. Einstein liked this idea very much. It nudged him toward general relativity. But here's the uncomfortable part. The final theory doesn't fully do what Mach wanted. You can still have rotating solutions even in empty universes. Space itself can carry rotation. So we're back to space being an active participant. Now let's make this more concrete. Sit on a rotating merry-go-round. You feel thrown outward. That's not a real force in the Newtonian sense. It's a bookkeeping force we invent because we're using a rotating frame. The Coriolis force, the centrifugal force. They're not new interactions. They come from how we choose to describe motion. But here's the catch. You can't describe the world without choosing some frame. And some frames are special. Inertial frames are the ones where the laws look simple. Rotating frames are messy. So nature itself is telling you which descriptions are special. And rotation is the thing that spoils the simplicity. Now think back to spin in quantum mechanics. There too, rotation plays a privileged role. The equations care deeply about how things transform under rotations, change directions, and the mathematics responds in precise ways. So rotation isn't just another symmetry. It's a central symmetry. At this point, you might start suspecting that the universe is built in such a way that orientation is fundamental. Not position, not motion, orientation. That's a strange conclusion. It suggests that the universe keeps a careful ledger of how things are turned, not just where they are or how fast they're moving. And once you accept that, a new possibility opens up. Maybe everything spins not because something started it spinning, but because the rules of the universe are written in a language where rotation is unavoidable. Now let's attack the word that's been misleading us all along, spin. When you hear it, you picture something turning, like a wheel or a planet. That picture is poison when you're talking about the deep structure of nature, because most of the spinning that really matters isn't anything moving around in space at all. Take an electron. It has spin. You can measure it, you can flip it, you can line a bunch of them up and get magnetism. But if you ask, what exactly is spinning, there is no sensible answer. Nothing is whirling around an axis. There is no tiny equator racing faster than light. So what is it? The honest answer is uncomfortable. Spin is how the object responds when you rotate the world. That's it. You don't rotate the particle. You rotate your coordinate system. You turn your measuring apparatus. You ask how the equations describing the particle change, and the particle answers in a very specific way. Some answers are simple. Rotate the world by 360 degrees, and the system looks the same. That's what everyday objects do. But some particles are not so polite. Rotate by 360 degrees, and the mathematics says, no, that's not the same state. Only after 720 degrees does everything come back. That's not motion, that's structure. It's like asking how a glove behaves when you turn it inside out. Left-handedness and right-handedness are not about motion. They're about orientation, about chirality, about the difference between mirror images. Now notice something remarkable. The universe cares deeply about this. The laws of physics know the difference between left and right in certain situations. Weak interactions break mirror symmetry. Some processes prefer one-handedness over the other. So orientation is not optional, it's baked in. This brings us back to the big spinning things, galaxies, stars, planets. We like to say they spin because of initial conditions. And that's true as far as it goes, but those initial conditions are constrained by deeper rules, rules that already know what rotation means. Here's another irritation. If spin were just an accident, you'd expect it to average out on large scales, half spinning one way, half the other, no preferred directions. And in many cases that does happen statistically. But the fact that angular momentum is even a conserved quantity tells you something profound. Conservation laws come from symmetries. Conservation of energy comes from time symmetry. Conservation of momentum comes from space symmetry. Conservation of angular momentum comes from rotational symmetry. So the universe doesn't just allow rotation. It respects it so deeply that it enforces a bookkeeping law around it. That means rotation is not a side effect, it's a consequence of symmetry. And symmetry is not something that happens after the universe exists. It's part of how the universe is allowed to exist at all. At this point, the question, why is everything spinning, starts to dissolve. It's like asking why everything has length or duration. Spinning is one of the ways systems can exist consistently with the symmetries of space. But this still leaves one last sharp question. If rotation is tied to symmetry and symmetry is tied to the structure of space, then where did that structure come from? And why does it look the way it does instead of some other way? That question drags us, whether we like it or not, straight into the origin of the universe itself. Here's where the story tightens and where bad explanations finally run out of oxygen. You don't get conservation laws for free. They come from symmetry. That's not philosophy, that's mathematics. And the person who made this brutally clear was Emmy Noether. Her theorem says this in plain language. If the laws of physics don't change when you rotate the universe, then there must be something conserved. Angular momentum. Not because nature likes spinning, but because nature refuses to care which way you turn your head. That's astonishing when you slow down. It means angular momentum exists because the universe treats all directions equally. Left, right, up, down. No preferred orientation. That symmetry forces the bookkeeping rule. And once the bookkeeping rule exists, spin becomes unavoidable. You don't need a reason for things to spin. You need a reason for them not to. Now think about the early universe. Hot, dense, everything interacting with everything else. Fields everywhere. Quantum fields, not little particles. Fields that can wiggle, stretch, twist. In such a universe, perfect stillness would be an incredibly special condition. You'd have to balance every wiggle, every fluctuation, every interaction just right. Any tiny asymmetry would get locked in by conservation laws. And here's the key point. The universe does not start by deciding what spins. It starts by deciding what symmetries it has. Once those symmetries are in place, spin is just one of the allowed ways things can behave. Think of it like this. If you design a game board with certain rules, some moves become inevitable. You don't ask why a bishop moves diagonally. That's the rule of the board. Spin is a diagonal move the universe allows. This also explains why spin shows up at every scale. Galaxies spin because gravity and symmetry allow angular momentum to collect. Electrons have spin because quantum fields transform under rotations in particular ways. Same symmetry, different manifestations. Now notice something subtle. The universe could have been different. It could have had fewer rotational symmetries or more exotic ones. In some hypothetical worlds, angular momentum wouldn't exist as we know it. Spin wouldn't be a thing. Matter would behave in ways we'd barely recognize. So when we ask, why is everything spinning? The honest answer is, because the universe is the kind of universe that permits rotation as a symmetry. That's not a satisfying answer emotionally. It doesn't feel like a cause. It feels like a constraint. But physics is full of constraints pretending to be explanations. We don't ask why energy is conserved anymore. We accept that time symmetry implies it. We don't ask why momentum is conserved. Space symmetry forces it. Rotation symmetry forces angular momentum. And once angular momentum exists, the universe fills it up like water finding every available crack. But there's still one last ditch. Why does the universe have these symmetries at all? Why this mathematical structure instead of another? Physics at this point shrugs. We can describe it, we can test it, we can use it to absurd precision, but the origin of the symmetries themselves is still an open wound. And that's where we end up, not with a mystical answer, but with a clean stopping point. The universe spins because it is symmetric in rotation, and it is symmetric in rotation because that's how the universe is built. The final step is to ask whether that's the end of the story, or whether asking why these symmetries is even a meaningful question at all. So now we're at the edge of what physics can honestly say without pretending. We started by asking why everything spins, and along the way, the question quietly changed. It stopped being about planets and galaxies and tops on tables. It turned into a question about why the universe bothers to keep track of direction at all. The cleanest answer we have is also the least dramatic. The universe is symmetric under rotation. Because of that, angular momentum exists. Because angular momentum exists, spin is not optional, it's allowed. And whatever is allowed in a universe full of interactions and fluctuations will happen. That's not a story about a cosmic shove at the beginning of time. It's a story about constraints, about what is permitted and what is forbidden. You can see this attitude everywhere in modern physics. We don't explain electricity by saying charges want to move. We explain it by saying the equations allow certain fields. We don't explain light by saying photons like to travel. We explain it by saying waves that obey certain symmetries propagate. Spin fits that pattern exactly. When a galaxy spins, it's not obeying some ancient instruction. It's settling into a state consistent with symmetry and conservation. When an electron has spin, it's not hiding a tiny wheel inside. It's expressing how its quantum state behaves under rotation. Once you see that, the mystery softens, not because it disappears, but because it moves to a better place. Instead of asking why everything spins, you ask why the universe has the symmetries it has, and that question may not have an answer in the way we're used to. It may be like asking why there are 3 dimensions of space, or why time goes forward instead of backward. We can imagine alternatives, we can write equations for them, but we don't know why this one won. And maybe that's the point. Physics is not in the business of comforting explanations. It's in the business of discovering which questions can be sharpened until they break and which ones dissolve when you understand the rules properly. So here's the unspectacular truth. Everything spins because the universe does not care which way you turn it. And because it does not care, it must keep track of rotation. And because it keeps track of rotation, spinning becomes as natural as existing. That's not mystical, it's not poetic, it's just how the bookkeeping works. And if that feels slightly unsatisfying, good. That discomfort is a sign you're asking real questions now, not reciting words that sound like answers.